Lab Guy here. In this video I'm going to prepare my sync generator demo board, my testing board. We're going to adapt that for use in the next video, which will be about how to use an analog oscilloscope to look at your video signal, your standard definition video signal in terms of its sync trains, blanking pulses, and so on. But before we can do that, I have to get the board ready. So I've drawn myself another pretty schematic. That I will be working from. Ignore the 2 one-shots on this schematic for the time being. We'll cover those in yet another video at a later date. One of my viewers, David Sutherland, said that he'd like to see more soldering and assembly work, so this video will certainly satisfy his request. Hopefully I got to this soon enough for his satisfaction. So David, I hope you enjoy this video. I hope the rest of you who are riding along will also get a kick out of how I construct my circuit boards and how easily they are modified for other missions. And then you'll see how I do all that. And why don't I stop talking and get on with it? So back to you, Lab Guy. Fire up the soldering iron. So this is the sync generator board, and I'm going to modify it to bring out the sync generator signals up to this row of test points. I've already stripped off the wires that were there. So we're going to bring out the wires from the sync generator and put them in the same order on the pins, on the test point pins, as they are on the drawing. So starting with vertical drive from pin 2 of the sync generator chip, which is right here, we're going out to this edge connector to pin 1, which is up here at this end, which is the top. Alright, I've already pre-stripped this wire, but you'll see me stripping wire to do this job. Notice that the wire is still attached to the roll. I pre-stripped about an inch, inch and a half at this end, and then I lay the insulation from the pin I want to go to the pin I want to come from, and bend it with the tweezers, and then use my strippers in the middle to loosen the insulation and pull it down a bit. So we solder this end on. I want to put some solder on these pins first. There's going to be a total of 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got enough pins on here. So I'm going to put the solder on all 8 pins to start with. Yep, bridged it. There we go. And make sure there's solder on there. Alright, now starting with vertical drive, I attach it to pin 1. Just like that. I grab the split insulation with the tweezers up here and push it down so that it bottoms out right here on the pin. Then I take it over to pin 2 on this chip over here. Take my word for it, it's pin 2, and I pull it up to the side of the pin and I kind of bend it around the pin and put some tension on it. Notice how straight and tight this wire is to the board. There's ground plane on the other side of the board, so when you do this, you're forming a proper transmission line. And then I just touch the heat to the solder on this pin, and the wire solders down. You take your trusty X-Acto hobby knife and you cut the wire. And that's that. Now we're ready for the next one. Pin 2 will be horizontal drive, which is on pin 7 on this chip. Oh, I have a wire floating. What happened? I believe that it came off of pin 7. That is correct. Pin 7. No, huh. Alright, well, we'll remove that for now. No problem. Okay, pin 2 on the test point is horizontal drive. That's pin 7 on the sync generator chip. We place the insulation at that pin. We pull it tight. We know this is the 16 pin chip. Pin 8, pin 7. So our pin 7 is right here. We take our tweezers and we grab our wire right there and we bend a 90-degree bend. We put a bend in it. That shows us where to use the strippers to strip. I'm using the second stripping hole on my strippers, which is 0.32 millimeters, 28 American wire gauge. I've stripped the wire so that the insulation is now separated up here, but the wire is not cut. We now solder it to pin 2. Once again, grab the insulation with the tweezers, can you see it? And slide the insulation down all the way to the end. Pull it up taut or tight, whatever you like. Toit, if you're gold member. And then solder to the pin. Cut with the knife. And we're ready to move on to test point 3. Now, on these rolls of wire, which I buy at Anchor Electronics in Santa Clara, California. You can look them up online. They're doing online business right now because of the situation. That which we will not discuss. So, anyways, this is the wire I get. It's rather pricey. It's, I believe, $15 a roll for this stuff, but these rolls are now going on 10 years that I've been using them, and this is the color I use the most, and there's lots of it left. So what I do is I cut this notch in here where I can pull the wire into the notch and it holds it. That way I don't end up with wire unspooling all over the table. So once again, we measure. So test point 3, Comp Sync, pin 6 on the sync generator chip. I've got a wire to remove first. So we'll take that off. There we go. I'm removing the old wiring because I don't remember what it was I was building on this board. Okay, now tweezers, wire, we measure. We're going to pin 6 from test point 3 to pin 6. Bend, strip, 28 gauge, 0.32 millimeter, pull, separated the insulation, solder it to test point 3, slide the insulation down. Well, if it fights you, you can use your thumbnail the same way. Bring it to pin 6 on the sync generator, which already has solder on it. Pull it tight. No, it's not tight. There we go. We get it down behind this other pin. There we go. And solder him down. Chop him off. Sometimes your tools like to fight back. Don't let them win. Never give up to an inanimate object. Pull out some more wire. I like to keep about 1.5 inches at this end cleared. Now we're going to do test point 4, Composite Blanking, which is on pin 4 of the sync generator chip right here. I have 2 more wires to remove. Hold on. I thought I'd stripped everything off. Oh well. That's what I get for thinking, huh? Oh, it wants to play. Okay, here we go. And those are off. There we go. Again, test point 4 to pin 4. Measure. 1, 2, 3, 4. There we are. Tweezers. Bend. Open a gap in the insulation. Solder. Pull the insulation down. Stretch the wire out to pin 4. Wrap around it. Give it a little tension. And solder it down. And cut it. We're going to do 8 test points here very quickly. Next test point. Odd field, pin 3. Test point 5. Alright, going from test point 5 to pin 3 on the chip. Bend. Put it in your strippers, close them all the way, give it a spin to cut the insulation and pull. Pull it down. I say pin 3, pin 3. That's our boy. Okay, need some solder. Fortunately, I keep all my solder numbered for such an occasion. Pin 3. Here we go. Alrighty. Cut. The next one is the even field square wave. Pin test point 6. Pin it down. That's pin 1 on the sync generator. Solder it down. Pull the insulation all the way down. Jump over here to pin 1. Well, for some reason we're just a skosh short, so we'll strip a little more and pull it down. There we go. Who wants to be a wise guy, but that's okay. There we go. You see? Then we cut off this wire. The next one is test point 7, which is burst flag. That's a pulse that occurs during the time when there's a subcarrier burst on an NTSC color signal. It's the same in PAL, but this is an NTSC sync chip. If you have a PAL sync chip, it will produce a burst flag, and it will correspond to the color burst on your PAL signal. Alright, test point 7 goes to pin 5. 1, 2, 3, 4, 5. 5 is open. Good. We measure to pin 5. There we go. Bend. Chop. Spin. Pull. Solder. Like that. And the last test point is subcarrier, and that is pin 15. I don't really need to bring it out. I don't know that I should, but I will anyways. The subcarrier output on this chip is a very low amplitude and requires buffering, but we're not doing color video, so we don't really care about that. But I'll put it on the test points just for completeness. And there we go. And we are definitely could use a little more. There we go. Alright. If it causes us some grief, like RF crosstalk or something, we'll remove it. But there we go. We now have 8 test points connected here and tied to the sync generator chip there, which is the Fairchild 3262. This is the crystal oscillator that drives it. These are the 4 NAND gates that shape the signal from this and turn it into bi-phase 14.31818181818181818 megahertz, which is divided down to 3.579545 megahertz plus or minus 10 hertz for the NTS Color Subcarrier system. All of the other timing pulses are derived from that frequency. The wiring on the back of the board is neat and clean, and the red wires are the power lines, the yellow wires are the signal lines. So that is some soldering and rework for the request for the viewer that asked for that. So there you have it. That's how I modify a test board for the next round of tests that it needs to be used for. Hope you enjoyed the video. So until next time, Lab Guy out.